Okay, so today we're doing, hi everybody, today we're doing lesson 26. And even though my hastily written objective says the same, it's a slightly different from lesson 25. We're still using the standard algorithm. We are using decimal division, but if you look at the bottom of lesson 26 in the problem set, it says we're dividing decimal dividends by two-digit divisors, so still using 2 on the outside, estimating quotients as we did before, but we're going to reason about the placement of the decimal point, and then we're going to try to connect to a written method. Now this is the best example of what we're doing today. We're going to take different dividends and divisors, okay, different dividends, different divisors, and show how you can get the same quotient up to a certain point and have the same remainder up to a certain point. And then we're going all the way back to Module 1, Lesson 15, where if you want to go watch that video again just to refresh yourself, you might want to do that. It's about annexing a decimal and a 0 or 2 and continuing your division and recognizing that when we have a remainder, that doesn't have to be the end of the problem. There could be more. And as you can see here, the exact answer is not 28 ones. It's 28 and 25 hundredths versus 28 and 5 tenths or 50 hundredths. And those are the exact answer, which means that this one is larger than this one. So that's what today is all about. It's about annexing, which means attaching to the end, the decimal and the 0, and continuing on. So let's get started. This 156 divided by 24 and 102 divided by 15 both have a quotient of 6 and a remainder of 12, just like our previous problem did. Are the division expressions equivalent to each other? Use your knowledge of decimal division. So like, they just spring that on you, don't they? To justify your answer. So set it up, 24 into 156, and set this one up. Okay, and then start dividing. You start the process. They're telling me it has a quotient of 6, so I don't have to do the whole, well, estimate. Well, they told you right here. Not much to estimate there. So they have a quotient of 6, so start your multiplication. 6 times 4 is 24. 12 plus 2, 14, and subtract. And they also tell you that you have a remainder of 12. So you could do the subtraction on your own. You can look at it, compare, make sure you get that. So let's stop that there. And then do the division here. They're telling us it's 6. 6 times 5 is 30. 6 times 1 is 6 plus 3 is 9. Do the subtraction, and you see you have a difference of 12. So this is what they're saying. Now we have been doing division and stopping here when we finished the ones place, and we said, let's just put the R and the remainder up. So we've been doing that for more than a week. And so you're kind of getting used to it. Well, just when you get used to it, we're saying, guess what? You don't have to stop here. This ones place is not the end of the number line. It's not the end of value. If you put a decimal, which already lived there, and you just bring this down and call this 120 tenths, you can continue dividing. We're going to get a nice detailed answer. So 120 divided by 24, I could guess about 5. If this was 25, I'd say 25, 50, 75, 100, 125, it's roughly 5, and then go ahead and start multiplying. 5 times 4, 20, carry the 2, there it is. 5 times 2 is 10, plus 2 is 12, and I get my exactly 120 tenths, 120 tenths. All right, then I'm going to do the same thing over here, annex, which means attach to the end, a decimal and a 0. Bring this down. You don't have to put it there. I'm just putting it there to help you understand. This is tenths. And now I'm going to divide 120 tenths by 15. Okay, so it's the same number, but it has a different divisor. It's 120 tenths. Oh my gosh, why do I keep saying that? But a different divisor. So I'm going to have a different number up here in my quotient. So it's going to be, this is less here, so this is going to be more. So I'm going to guess about an 8, okay? Because if I was counting by 15s, I would do that. You can do your estimation. 8 times 5 is 40, and I want to recognize that when I'm estimating, I want to consider what facts I know and kind of do the multiplication in my head. So 8 times 5 is 40. And then I'm looking at this going 8 times 1 is 8, but plus 4 is 12. And so I'm seeing that when I work this out, I'm going to have 0 remaining. So what does this mean? We started with the same quotient and the same remainder. But when you annex the 0 and continue your division process, you get something that is different. They are not equal, okay? This one is greater. And so you have to use this strategy to show how these are not equal. Okay, so 8 tenths is greater than 5 tenths. That's what today is all about. So let's do some more. Now that you know how to do it, it says construct your own division problem with a 2-digit divisor. Okay, you have to use 2 digits. You can't use a single. Why? Because the remainder. Because that has a quotient of 6. Okay, they're telling you again, you have to use that. And a remainder of 12. But it's not equivalent to the problem in 1A. So here's where you pick. You pick. And yours doesn't have to be the same as mine. What you do is you have to pick something larger than 12 because you cannot have a divisor that is less than your remainder. Okay? So start with 13 or higher. Let's just pick, you know what, I've had kids pick 45 in the past. They're like, let's do a big one. So you pick. You can pick anything 13, 14, 15, 16, 17, 18, and so on. But I have used 18 in the past, and I got this never-ending decimal. And sometimes you get those, and oh well, that's a lesson for another day. So let's say we pick 45. You pick any greater than 12. Okay, and yours can be different. Well, you're going to multiply it by the quotient of 6. So that's step 1. So you pick, multiply it by 6. 6 times 4 is 24, 5, 6, 27. My answer is going to be different from yours unless you pick 45. Then you add the remainder. And this is your new dividend. So you could set it up with 282 divided by 45, which would give me 6. 6 times 5, 30, 24, 25, 26, 27. And I get the remainder of 12. Okay? My new problem, my own, has a quotient of 6, yep, and a remainder of 12, yep, and it's not equivalent to this one. So let's keep dividing and see what happens, okay? So if I had 45, it's roughly 50. So I could try 2. And again, if I have to erase and start over, it's okay. 2 times 5 is 10. And then 8 plus 1 is 9. And subtract 9, 10, 11, 12. So I have my next chunk is 30. 30 tenths. So 300 thousandths. And I could keep going. And I can see already that 6.2 is not equivalent to these. And so I can keep on dividing. And, you know, so your number may finish out quickly, or you may have to keep on dividing. And if I'm going to go pretty high, I could guess about an 8. And then 5 times 8 is 40, and then 32, 30. Oops, too high. So that's what you're going to keep doing. But we don't have to continue on. But it's really just showing you that this is not equivalent, And so if you choose your divisor and it's any number over 12, and yours can be totally different, multiply it by 6 and then add 12 to get your dividend. And then start dividing, get at least this far to the 10th place to show that it is not equivalent. And you can continue, but I don't want to run out of time because sometimes these take a long time. All right, and we still have quite a bit of work to do. So moving on, divide, then check your work with multiplication. And so set it up, 13 on the outside, 36.14 on the inside. First thing you do is put the decimal up in the quotient. Decimal up. Okay, and then how many times can I fit 13 into 36? I could try for 3, but it'd be 39, and so I just know I'm going to have to go back down to a 2. And then I would get 26 and left over with 10. Bring down the 1, and again, this is all place value, so it's like 101 tenths. And then divide that by 13. This is where you have to start estimating. And you said if I had 10, it would be 10, but I can't have 2 digits, and I have more than that. So I could try like an upper digit, let's 8 or 7, let's go with 7. 7 times 3 is 21 because you have to consider all the extras you're carrying over. I'm carrying over 20 extras. 7 times 1 is 7, plus 2 is 9. So I'm pretty close here. Only 10 away, and 10 is less than 13, so I can move on. Now this is the bring down, and this is the bring down. So finally we're using that B, the brother from the division family, and we're bringing down the next digits. 104 divided by 13. Excuse me. And we can guess about 8 because I'm really close with 7, but I have a little bit more room. 8 times 3 is 24, and then 8, 9, 10. Okay, so 2 and 78 hundredths is our quotient, but we also need to check. Okay, so we're going to check our work. 8 times 3 is 24. 7 times 3 is 21, 22, 23, and then 6, 7, 8. Okay, now we're done with this one, so hold that spot with the ghost 0, and then move on to the 10. So it's really 10 times 8 is 80, but we can just say 1 times 8 is 8, 1 times 7 is 7, 1 times 2 is 2, because I already have this place held. Then add 8, 9, 10, 11, 9, 7 is 16, and I have the 3614 just like I have here, but where does the decimal get put back? Another lesson. Remember from weeks ago, when multiplying with decimals in your factors, the short way was just how many places exist to the right of the decimal. If this is in hundredths, THS, it's abbreviated, then this should be hundredths, THS. So it is, and this matches, and therefore we are correct. And you can section off your work to kind of give yourself a little organizational space. Okay, so let's do another one. 23 and 62 79 hundredths is our dividend. Decimal up, first thing. If you can't do anything else, at least you can put the decimal where it belongs on top. Now 23 can fit into 62, but if I tried to do it 3 times, then I would be over. So I'm going to have 2 times. 2 times 3 is 6. 2 times 2 is 4. So you have to think about where, what number to put up there, and you're kind of estimating, and it's all in your head now. Okay, so standard algorithm, subtract, take 1, give 10, 12 minus 6 is 6, 5 minus 4 is 1, and then we compare. 16 is less than 23, so I can move on. So I have 167 tenths that's being divided by 23, and if I was going to count by 20, I don't want to go past this. 8 would be too high because I have 8 times 3. That would get me up to 24. So I'm going to try a 7. So 7 times 3 is 21. 7 times 2 is 14, 15, 16. Look at that. It was so close. Subtract and get 6. Then we already brought this down. Now we get to bring down the 9. 69 divided by 23, and that would be 3. 3 times 3 is 9, and 3 times 2 is 6. And so you may have seen that coming. And it's lovely when you get down here and you have 0 remaining, because then you don't have anything to add. You just check with multiplication. So, oops, almost wrote the dividend again. 2.73 times 23. And 3 times 3 is 9, 3 times 7 is 21, and then 6 plus 2 is 8. Hold this spot with a ghost. 2 times 3 is 6, 2 times 7 is 14, 2 times 2 is 4 plus 1 is 5. Add these, 7, 8, 12, and 6. Now I have 6279. Hooray, but where does the decimal go? Don't forget, hundredths here, hundredths here. Compare, and it is all good. Okay? For the bottom two, I'm just going to show you the answer key before I turn the page, because I don't want to go over time, and we have kind of a long lesson. So the last two, I know it will focus momentarily, but you can kind of see until it focuses. In the meantime, pay attention, iPad. Thank you. I have to talk nicely. So 12 and 21 hundredths divided by 11. So 12 can be divided by 11 one time. Multiply, subtract. Get this, bring down. It starts to look all the same until you get down here to the last one. Do your multiplication. Ah, the lights. It wouldn't be a normal day if I didn't have some kind of problem on here. And here's your final answer, 12.21. Last one, set it up, 13 on the outside, 6.89 on the inside. This one does not have a value in the ones place because 6 is not divisible by 13. So you regroup 68 tenths, divide, get 5, do your multiplication, subtraction. When you have 3 left, bring down. 39 divided by 3 is 3, multiply, get 0. Do your check, okay? This one can go on top because it would have 3 digits, and or you can switch it around and just make sure you have the 0.53. You may have different partial products if you switch the order, and you end up with 6.89, which is what you started with. Okay, so let's go to the back, do a couple problems together. And actually, maybe we'll just do the word problems together. So I'll show you these just for speed's sake. And so you can kind of copy, but let me talk you through them real quick. Here's the division, 52 on the outside, 249.6 on the inside. So again, 24 is not visible, but 249 is. If you use 4, because 50, 100, 150, 200, I would not get to 250, and it's over 50. So use 4, multiply, subtract, compare, it's good, bring down. Divide this by 52. We would get 8. Now you have the benefit of seeing that it's already done. But again, use 50 in as your rounded number in your head. And so you would go ahead and guess 8. 8 times 2 is 16. Then you get 41 and you have 0. Check with multiplication and then add. When placing the decimal, this one has 1 decimal spot to the right of the decimal. This is only tenths, therefore your answer is tenths. Next one, division. Divide with the decimal and approximately 50. Can't fit into 24, so you start with 249 tenths. And then if you were using 50, you would guess 4 times because it's actually greater than 50. Multiply and get 208, subtract and get 41, bring down. This is less than, see the little comparison? Now 416 divided by 52. If you had 50, you would guess around 40. That would give you about 8. 8 times 2 is 16, carry the 1. 8 times 5 is 40, plus 1 is 41. Subtract and you have nothing. Take this and multiply it by this. You can do either order. And then when you add, you're going to end up with 2496. 2 places for the decimal here, 2 places here. Same thing down here. We're going to set it up with division. If I had 60, even if you had 50, like you could round it to 50 and then just count and guess. So you've got your 5 times 59 for 295, which is only 5 away from 300. Bring down the 59 and you have another full set. That one's real easy. Multiply. So what do? You have tenths here, tenths here. And the last one, sorry, I'm going so fast. 30.09 divided by 59. 59 won't fit into 30, but it will fit into 300. And so if you guessed your 5, then you can work it out. Subtraction. 5 times 59 is 295. Subtract, get 5. Quick compare, that's good. Bring down 59 and it's another full set. Okay, and so if you don't guess these, or if you, I know it's like I'm giving it to you right here, but in the homework you may have to guess something and it may be a little bit more work, and if you have to erase and start over, that's just perfectly natural. Okay, and then this one I have had it showing, so we may as well just talk about it together. The weight of 72 identical marbles is 183 and 6/10 grams. What is the weight of each marble? Okay, well, you're going to take the total number of the grams and divide it by the 72 marbles. Notice that I labeled everything so that you can see what you're dividing. Okay, and then you start, you can't do 18, so you do 183, and if this was about 72 times 70 is 140, so you're going to go past it if you have 3. So you multiply this 2 times 72 and get 144, and that leaves you with a remainder of 39, which is less than 72, so proceed. Bring down the 6. 396 divided by 72. So if I had 70 times 5, I would get 350. So I can use 5 because I have a little bit more than that, and then I get 360. And then I subtract and I have 36 left. And if you look and you say, well, I have 36 and I bring down my 0 and I have 360 and I need 360. So you can guess 5 again and notice that that's going to give you a 0 outcome. You just have to look for those things because it's right there. It's going to be right in front of you. Anyhow, so the 2.55 or 2 55/100 grams each is the weight of each marble. Now, how do you know how to put the decimal point placed correctly? Because you can talk about your rounded answers. So when we're talking about 70 and 140, it would need to be more than that, which is, if you ended up with 183, okay, this is what we have here. If you ended up with 25, that would be like way too big, okay? And if you ended up with less than 2, like a 0.255, that would be too small. So you should be reasoning your way through these problems with just kind of good guesses. All right, you know what? This lesson's going to go so long if I have to do it, so I'm going to just show you the answers. Cameron wants to measure the length of his classroom using his foot as a length unit. His teacher tells him the length of the classroom is 23 meters. So he steps across the classroom heel to toe and finds that it takes him 92 steps. How long is his foot? So if you take the full length of the room, which is 23, and you would start with just 23, that's what's helpful about when I'm writing it for you. So you would take the 92 steps, and we're really dividing the 23 meters. Ooh, my pencil is almost out. And so you might say, well, I can't do that division. This number is too small, and I would say, you're right. So we put a 0 there, but annex the 0 and continue dividing. So that's what I'm talking about when I have the answer like this, continue dividing. So once we have this 0 here, you can approximate 90 times 2 would be 180. So we're getting really close to the 230. So 2 times 2 is 4, 9 times 2 is 18. And then subtract, and standard algorithm, take 1, give 10. 10 minus 4 is 6. 2 minus 8 you can't do. Take 1, give 10. 12 minus 8 you can do, and you end up with 46. It doesn't matter that it's a big remainder. It's still less than 92. but it's not the end. I'm going to annex another 0 and bring it down, and then think about 184 in terms of how many more 92s to get to 460. So we know from the answer key on the other side that it's about 5. You would guess maybe 4 or 5. 5 times 2 is 10. Always look for that answer, the 5 times 2, and what number will you get in the ones place? Is 10. 5 times 9 is 45, plus 1 is 46. So there you go. And his foot is 25 hundredths of a meter long. And the last problem, super challenging. Okay, I got a couple minutes. It's really better if I just draw it for you. A blue rope is 3 times as long as a red rope. So we have a red rope, red. And then we have blue, and it's 3 times as long. 1, 2, 3. That's lovely. But now we have a green rope, and it's 5 times as long as the blue rope. So if this is 1 green, 2, 3, 4, 5. And how many are in each one? If I was to break this up, it would look like this. If the total length of the 3 ropes is all this is 508 and 25 hundredths meters, all that together, what is the length of the blue rope? Okay, again, when I would start as a 5th grader, there's no way I could have ever gotten this without the use of a tape diagram, okay? But when you look at how many pieces you have, these are all evenly sized. So how many pieces are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. We're going to take the 508 and 25 hundredths, and we're going to divide it by 19. And that is what we have here. So we can wrap it up. So now you can see how to solve this. First of all, it's a read, draw, write. Read it, draw what you can. Realize that when you add them all up, you have 19. When you find the size of 1, okay, because this is the size of 1, 508.25 divided by 19 would give you 1 piece, which is actually the red. So when it says what's the length of the blue rope, you have to multiply that red size, 26.75, times 3 to get the blue. So super challenging lesson, lots there today. I hope it's helpful. I really hate just putting down the answer key because I want you guys to know how to solve these and not just what the answer is. But I hope it has helped you. And they don't even care about how long the green is. That's not even a question. It's just how long is the blue. So there you go. If it was helpful, you can click subscribe, and then you'll be notified when I have uploaded a new video. Sorry it's so long. You guys have a great day.